This is lesson 43, and this is developing and using something called the unit circle. Again, people seem to have different, levels of what they remember or what they've seen before. But if you don't know too much about the unit circle, then today is the day for you. So to get us started, a little bit of a recall. The unit circle, remember that is by definition a circle with a center of 0, 0 and a radius of 1. If you were to put that in equation form, x squared plus y squared equals r squared, and again, r is just 1. The fact that x and y have no parentheses is because there's no shifting, and it's just a center of 0, 0. So now that we know that, we're going to go ahead and take that and create an actual copy of the unit circle. So notice that underneath you have a circle with a bunch of blank spots, which we're now going to go ahead and fill in. So the first thing they want you to do is on the inside of the circle, they want you to indicate all the different degree measurements from 0 to 360. So I had told you that there'd be some color coding. We're going to do that color coding with highlighters after I write it. So again, when I do the color coding, I will let you know so that you can follow. So taking a look at a circle here, technically remember that whenever you start, you're starting in standard position. So you would always be starting at 0. If you were to go one full complete revolution around the circle, that would be a full 360 degrees. Then consider what if you went halfway around the circle. So if you went halfway around the circle, that would be half of 360, which would be 180. Then consider if you took that half of a circle and folded it in half again. So half of 180 would be 90 degrees. And then if you look at those quadrantals, you essentially counted in 90. So at the top would be 90, at the left would be 180. That means that all the way at the bottom would be 270, and then one full complete revolution would be 360. Just something to point out here, in a normal year, you would have to memorize all of this. You would have timed quizzes to make sure that you could give me this information in a timely fashion. Obviously, that's not possible this year, but I still would strongly recommend that you try to memorize as best you can. Not only is it just going to make your life easier this year, but it will make your life easier in the future. So any question at all where I got any of those values? Basically, you traveled around the circle counting by 90s. What if now we took the first quadrant and we took that 90 degrees and we cut it in half? If we were to cut it in half, this would give me a degree measurement of 45. What that means is every time you go half of a quadrant, you're going 45 degrees. So you would go from 0 to 45. Then you would add 45, and that would bring you to 90. If you added 45 again, that would give you 135. 45 again would give you 180. Plus another 45 would put you at 225 in quadrant 3. Another 45 would give you 270. One more time of 45 would give you 315. And then one full time around the circle would be 360. So essentially, even though we started by counting with 90s, you could just count by 45s and you'd be able to fill in all of those tick marks. Be careful that you're not only filling in the right answers, but make sure you're filling them in the right slots. Any questions or comments or thoughts about how I got those degree values? Okay, and again, just as a reminder, the way that I am creating this circle for the first time, this is how you could duplicate it in the future. You could start by counting by 45s, and that would give you all those values. To find all the missing values, take again a look at the first quadrant. Instead of cutting it in half, suppose instead you divided it into thirds. So if you were to divide it into thirds, you would get this right here. So basically that first tick mark would be 30. Then you would count 30 to get to the next tick mark and then count 30 all the way around. So that's what we're going to do to fill in the rest of the circles. So this first third of the circle is 30 degrees. Plus 30 would give me 60. Another 30 gives me 90, which is already there. 30 again makes 120. Followed by 150. Followed by 180, which is already there. then 210, plus 30 is 240, plus 30 is 270, plus 30 is 300, 330, and then another 30 would bring you all the way around to get back to one full revolution of 360. So those are what we call the degree values of the unit circle. And again, you can duplicate those values at any time, either by memorizing them or simply doing what I did here, counting by 45s or counting by 30s. So give you a second to fill any of that in if you need to. And are there any questions before we now go ahead and talk about what that would look like with radians? Okay, so because of the fact that we went around and counted in multiples of 30 or 45, every single one of those answers is a multiple of 30 or 45. So we're going to go ahead and convert those specific values into radians. So remember to do that. You would take 45 degrees and you would multiply it times pi over 180. If you were to reduce the 45 and the 180, you would wind up with a value of pi over 4. If you were to do similarly for 30 and multiply by pi over 180, that would reduce to be pi over 6. So another part of what today's lesson is, make sure that looks more like a pi, is these values on the unit circle, the conversions literally never change. So once we fill these in the first time, they're going to be true always. So we're now going to go back around the circle and we're going to write each degree measurement as an equivalent radian statement. And we're going to use those two facts that we just found about pi over 4 and pi over 6 to help us. So if we kind of go around the circle the same way that we did the first time to make the 45s and the 90s, we're essentially going to count in pi over 4s. So starting with 45 degrees, that is going to be equal to pi over 4. And then we're going to go around the circle and we're going to count in pi over 4s. So if I add another 45, that brings me to 90. That's pi over 4 plus pi over 4, which is 2 pi over 4. And 2 pi over 4 reduces to be pi over 2. If you add 45 or add pi over 4 again, remember it was 1 pi over 4, 2 pi over 4, and now 3 pi over 4. Then 4 pi over 4 would give you 180. If you count it again, that would give you 5 pi over 4. If you, so 3 pi over 4 and then 4 pi over 4, and 4 pi over 4, of course, reduces to just be pi. Another pi over 4 would be 5 pi over 4. At the bottom would be 6 pi over 4, and 6 pi over 4 reduces to be 3 pi over 2. That would make the next one 7 pi over 4. And then all the way around the circle would be 8 pi over 4, which is equivalent to 2 pi. And remember, that's what we talked about yesterday, the fact that the circumference of the unit circle was 2 pi, which means exactly 1 revolution. So what we built there is actually some of the families of the unit circle. That's actually 2 of the families. We'll do the colors in a minute. But again, if you were trying to duplicate this in the future, you could do so by following these same steps. So let me give you a minute in case you're writing anything down. And again, are there any questions? Okay, so then finally, now that we know that 30 is equal to pi over 6, we're going to go around and count each of those tick marks as pi over 6, and we're going to reduce where possible. So 1 pi over 6, then this would be 2 pi over 6, but 2 pi over 6 reduces to be pi over 3. At the top would be 3 pi over 6, which reduces to pi over 2. Then this would be 4 pi over 6, but that reduces to 2 pi over 3. That would make this 5 pi over 6. Which would make the next stop 6 pi over 6, which again is pi already there. Which would make this 7 pi over 6. followed by 8 pi over 6, but 8 pi over 6 reduces to 4 pi over 3. The bottom would be 9 pi over 6, which reduces to 3 pi over 2. Then 10 pi over 6, but that's really 5 pi over 3, which makes the last tick mark 11 pi over 6. And then one full revolution would be 12 pi over 6, which again is equal to 2 pi. So what we have created here are what are called the 4 families of the unit circle. How do you know who belongs in each family? Well, it has to do with their denominators. So you would say that all the quadrantals, those are one family. So if you're a highlighter person, you would make everything that's at a quadrantal one family. Then everything with a 45, that would be a different family. Careful with the last family. So pi over 6, make sure you're aware that it's not necessarily in the same location each time. It's always the ones that are closer to the x-axis, which would make your final family the pi over 3 family, and that's everybody who's closer to the y-axis. So again, whether you've seen this before or not, these are all the values of the unit circle. You should be able to memorize them, duplicate them, create them again whenever possible. Again, if it's your first time, great. If it's more than your first time, even better. But go ahead and take a minute to make sure you've got all that. Remember, if you don't have any highlighters handy, you can always go back at any time and add those in. But questions up to here? Okay, so then if we go ahead and scroll to the next page. So now we have another copy of the unit circle, but notice we're going to approach it slightly differently. On the blanks on the inside of the circle, we're going to write the radian measurement. So it's the same radian measurements that we did from the back. I'm going to go ahead and fill them in. You can fill them in either by following me or by trying to see if you can fill them in on your own. Either way, they're the same exact values from the previous page. So give me a second to do that. Okay, so again, you could duplicate this by counting in pi over 6s or by counting in pi over 4s. And again, making sure that you reduce all the way along the way. I'm just double checking that I've done all of that correctly, which it looks like I have. And now here's what we actually want to know. So now that we know how each degree measurement is equivalent to a radian measurement, we want to go ahead and figure out what are the actual coordinates of those points on the unit circle. And in order to do that, we're going to use the definition and the fact that the circle has a radius of 1 and has a center of 0, 0. So notice what I have there is just a little part of the unit circle in the first quadrant. And what I want to do is I want to consider each of the different families. And if I'm going to consider each of the different families, the first one that I'm going to consider is the 45 degrees. So think about what that would look like. That essentially means that I would be cutting the quadrant exactly in half. If I was to drop a perpendicular, that would be a right triangle. The radius of the unit circle has to be 1, which is the hypotenuse. That would make 45 and 45 for each of those angles. What we now want to figure out is if the length of the radius is 1, which again, it has to be if it's on the unit circle, what are the lengths of the other two sides? And thankfully, there's an app for that. There's a formula. And so as a little reminder, I'll kind of do it on the outside to give me a little bit more room. Remember, if you have a 45, 45, 90 triangle, remember that the two legs are always x, and then across from the 90 is always the square root of 2 times x. So if I take those relationships and I use the fact that in this particular case, the length of the hypotenuse is 1, I would set the square root of root 2x equal to 1, which would mean that x was equal to 1 over radical 2, which means that x is equal to radical 2 over radical 2, which means that this x distance on the triangle is radical 2 over 2. This y distance is radical 2 over 2, which means if I was to write an ordered pair for the x value, comma, the y value, it would be root 2 over 2, comma, root 2 over 2. Because of that fact, if I go back now to my unit circle and I go to pi over 4, I'm going to go ahead and write that ordered pair as the square root of 2 over 2 and the square root of 2 over 2. Then here's the thing. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If I consider the triangle that's made here at pi over 4, and then I was to consider the triangle that would be made here at 3 pi over 4, and if I consider the one at 5 pi over 4 and 7 pi over 4, that is going to give me 4 congruent triangles. They all have the same reference angle. Remember, that's what we talked about last time. So since they all have the same reference angle, that means they're all going to be the same exact x and y distance. The only difference is the fact that the positivity and the negativity changes based on the quadrant. So at 3 pi over 4, it's going to be negative root 2 over 2, root 2 over 2, because of the fact that in quadrant 2, you're going to be negative and then positive. It's okay if you have those triangles drawn. I'm just going to erase them so I have a little bit more room. Then down here at 5 pi over 4, you're going to have a negative root 2 over 2 and a negative root 2 over 2 because the x and the y are both negative, which would give you root 2 over 2 and then negative root 2 over 2 here in the fourth quadrant. So make sure you're writing them in the appropriate slot in the pi over 4 slots. And questions? Okay. Consider what happens when the radius is at its long, like when there's no triangle at all. So because the radius is 1, when it's pointing all the way to the right, that would have a value of 1 comma 0. When it's pointing all the way to the left, that would be negative 1 comma 0. When it's pointing all the way up, that would be 0, 1. And when it's pointing all the way down, that would be 0, negative 1. Again, our whole goal here is to fill in all of these values. Awfully quiet out there. Are you guys still there? Okay. All right. Well, in the same way that we took the ratios of the 45, 45, 90, we're now going to take those same ratios for the 30, 60, 90. So now consider what would happen if I was to create each of those. So let's go ahead and consider what would happen if we did the 30 degrees. That would make this 60. And then that would be 90. Remember, that would have a radius of 1. In order to figure out what the other two values would be, we're going to go back to what we know about the ratios of a 30, 60, 90 triangle. So let me go ahead and, can't seem to draw a good one. Okay. So hopefully you remember or you're able to refer to the ratios of the 30, 60, 90. So across from the 30, that's always the x. Across from the 60 is always the square root of 3 times x. And across from the 90 is 2x. So keeping that in mind, the fact that the hypotenuse is 1, that means that 2x is equal to 1. So that means that x is equal to 1/2. That means that if I was to try to fill in this ordered pair, the if I was to fill in this value here, that would be a value of 1/2 from the top to the bottom. Then in order to find the horizontal distance, you would do the square root of 3 times x. So that's the square root of 3 times 1/2, which would be the square root of 3 over 2. And that's going to go here. So that's going to make this ordered pair the square root of 3 over 2, comma, 1/2. So when you have the 30, 60, 90 triangle, and when you have the 30 at the origin, you're going to have that ordered pair, square root of 3 over 2, 1/2. And again, it comes from the fact that the 30, 60, 90 triangle is part of the unit circle. And it comes from the fact that these are always the same ratios. So let's go back up here again to our circle. So at the triangle where 30 is at the origin, that's the pi over 6 family. So this here has a value of root 3 over 2. It doesn't have to be a different color, but I'm just trying to make it easier to see. So root 3 over 2, 1/2. Then over here in the second quadrant, it would be negative root 3 over 2, 1/2. At 7 pi over 6, it would be negative root 3 over 2, negative 1/2. And at 11 pi over 6, it would be root 3 over 2, negative 1/2. And again, just to be clear, if you have any question at all how I know the positivity and the negativity, make sure you know. So anything in quadrant 1 is always going to be a positive x and a positive y, where anything in quadrant 2 is going to be a negative x and a positive y. Anything in quadrant 3 is going to be a double negative, and anything in quadrant 4 is going to be a positive negative. That's not only how the unit circle works, but that's also just how any ordered pairs in the quadrants work. Okay, to fill in the last round, I actually don't have to do any more work. I just have to make sure that I know how to take what I already have and turn it into something else. So let's see if somebody can help me here. If this is my 30, 60, 90 triangle, when the 30 is at the origin, if I was to draw a triangle at pi over 3, it's the same 30, 60, 90 triangle, except now the 60 is at the origin. Can anybody tell me how the ordered pair would change if the orientation of the triangle changes? Like, can anybody? Go ahead. Oh, sorry, I couldn't hear it. Try again.
Can you hear me?
Yep.
Would it just flip?
It would absolutely flip the x and the y. So it would be 1/2 radical 3 over 2. And again, the reason why that is because all you're doing is rotating the triangle, which means the measurements are all still the same. They're just in the opposite location. And then go ahead and fill in the rest. So that would make this negative 1/2 radical 3 over 2. That would make this negative 1/2 negative radical 3 over 2. And that would make this positive 1/2 negative radical 3 over 2. So let me give everybody a minute or a couple of minutes just to go ahead and make sure that they've got everything exactly where it belongs. Make sure that you have the correct positivity and negativity. Again, notice that everybody in quadrant 1 is a double positive. Notice that everybody in quadrant 2 is a negative positive. Notice that everybody in quadrant 3 is a negative negative, and notice that everybody in quadrant 4 is a positive negative. So the previous page and this page are so important. Again, in a normal circumstance, I would be asking you to memorize and fill in these circles quickly without a calculator. We obviously have to change that up a little bit for our current circumstances, but the the more you can memorize and understand where all these values come from, I just think the better off it's going to be for you in the long run. So again, let me give you a minute or two to digest, write everything down, and I would love, love, love to answer a question if anybody has one.